Pat and Visalakshi have something surprising in common.
They're two faces of a disease that in the last few decades has become a global epidemic.
I diagnosed when I was 31 years that I have diabetics. Both my parents have, both sides my grandparents had. So I thought I should better check myself.
The doctor calls me and says, Pat, I have to be the one to tell you you have type 2 diabetes. And my first reaction was, who said? Wasn't it just a fluke? She goes, no, you have diabetes.
Type 2 diabetes is usually portrayed as a Western disease.
So it was a complete shock to us when we found out that 80% of the cases are now in developing countries. A simple explanation for this is that globalization is spreading a Western lifestyle around the world.
More and more, people like Visalakshi have access to the same processed foods and modern conveniences as people like Pat.
But it's actually the differences between these two women that brought us to India. Because those differences are causing scientists to profoundly rethink their understanding of this disease.
If you didn't know India had a diabetes problem, some of the numbers will be shocking. They certainly were to us. 66 million people here have type 2 diabetes, and that number is growing rapidly.
To get a sense, we visited Dr. Mohan's Diabetes Specialties Center in Chennai. His network of diabetes clinics has over 300,000 active patients.
The projections are it will cross 100 million people in 2030. That is the official IDF projection. If you want to take my view on it, yes, we'll get to that number, but it will be much faster. In fact, what they had said was that we will reach, when it was 30 million, they said by 2025 we'll reach 50 million. Here we are at 68 million now. And the number with pre-diabetes, the stage before diabetes, is 77 million people. So things happen much faster. 65% of the population today in Chennai has either diabetes or pre-diabetes. So the normal people are actually in minority now.
There's no doubt that changes to diet and physical activity are part of the story. According to some measures, India has the fastest growing economy in the world right now, and that rapid development is changing the way people live.
People were traditionally very thin. They were poor. They had nothing to eat for many years. People had to walk in the past. To get to school, you had to walk 2 miles. If you work in the field, then you're plowing the field. If you had to get water, you had to go and draw it from somewhere and then carry the water. It's completely changed from the way it used to be just 30 years ago.
So is this like almost like a bad news part of a good news story?
Exactly. What happens? Electrification comes, and then water supply comes to the village. The bus stops get closer and closer, so 100 yards from you, the bus stops, so it's convenient. This is progress.
From here, it's easy to jump to the conclusion that progress leads to a fatter and lazier population, which leads to diabetes. But there's a kink in that story. While the US is one of the fattest countries in the world, India remains one of the thinnest.
Medically speaking, you're considered overweight if your body mass index is above 25. If it's above 30, you're obese. In the United States, obesity and type 2 diabetes largely go hand in hand.
But in India, the face of diabetes is a skinnier one. To scientists who study these things, this is a major mystery.
So if you read a standard textbook of medicine, the biggest risk factor for diabetes is age and obesity. So increasing age and being overweight and obese. But as soon as I went to England and started sitting in the clinic in Oxford where I trained, I could see the patients there were very different than what I was seeing in India. So then I realized that Indians get it at a younger age and at a lower body mass index.
And then the next question is why?
Why?
Right?
Exactly, why?
Dr. C.S. Yajnik has spent the past 2 decades trying to answer that question.
And in the process, he's transformed this diabetes clinic at KEM Hospital in Pune into a leading center for research. He started by taking a closer look at his patients, and he found that BMI wasn't telling the whole story.
Body mass index first came on the scene in the early 1940s when a statistician at the MetLife Insurance Company noticed a correlation between BMI and life expectancy.
In the decades since, it's been widely adopted as a measure of health. But all it really is a ratio of weight to height. Yajnik set out to find something more concrete.
These two instruments made a big difference. Okay, this is a skin caliper. You catch hold of your skin fold so that you can measure how many millimeters. And it's a measure of fat under the skin. And this instrument, which is even simpler, it's a measuring tape.
Using these two instruments, Yajnik realized that though many of his diabetic patients looked thin and had low BMIs, they actually had a lot of fat. It was just hard to see.
And I coined a term which confused everyone, saying Indians were thin but fat. And people really didn't believe it. In fact, some of our original papers were resoundingly rejected by major journals across the Atlantic. So they didn't say your idea was wrong or anything. They said this is of no interest to our readers. You start thinking if the address was not KEM Hospital, Pune, but someplace in northeast of US, for example, then they would have said, what a great discovery. Hello.
Hi.
Hi, John.
So then Yajnik and his colleague John Yudkin of University College London found a more dramatic way to prove the point.
All right, how does that look?
That looks perfect.
What about this picture that was published? Where did the picture come from?
This picture, which they called the YY paradox, originated when the two researchers decided to run some tests on themselves.
We thought it would make a nice little teaching exercise.
The first shock. Oh.
The first shock came when Yajnik and Yudkin discovered that they had the same BMI.
The BMI was 22.3, which for an Englishman is little BMI.
And when they measured their body composition, using a new machine called a DEXA that Yajnik had just purchased for his clinic, they got another shock.
I had never expected my body fat to be more than twice as much as yours.
We submitted it to the Lancet.
It was eventually published in 2004, along with a short caption pointing out the limitations of BMI when comparing different ethnic groups.
We wrote that in 20 minutes' time.
I think you did that only to get your average length of time of writing a paper down to 6 years from 12.
That's right.
We decided to repeat the experiment on me.
So is this is me here, that little arrow?
I had a BMI of 22.7 and a body fat percentage of 23.9.
So can we see yours?
Yeah.
Dr. Yajnik's BMI was lower than mine,
Wow.
but his body fat percentage was much higher.
I'm ashamed of it now.
The shortcomings of BMI are now widely accepted, at least in the scientific community. When it comes to health, what matters is how much fat you have, not how fat you look.
It also matters what kind of fat you have. And Yajnik found that Indians tended to have more fat in their abdomen, so-called visceral fat, which many researchers have found is strongly associated with diabetes risk. But understanding how Indians are different doesn't explain why they're different.
An obvious answer would be that it's genetic. But Yajnik stumbled on another possible explanation when he heard about the work of a British epidemiologist named David Barker. Barker was studying something that wouldn't seem related to diabetes at all: fetal malnutrition.
If there is poor environment very early in life, that means when you're growing in the womb, then what do you get? You get low birth weight. And he then found records in Hertfordshire where a nurse had gone around measuring babies at birth and serially in first few years of life. So he traced about 500 of these people, studied their metabolism, studied their heart disease risk and other things, and produced this remarkable data that people with low birth weight were at a higher risk of heart disease and diabetes.
This was a radical idea. These diseases, after all, were often blamed on too much food. But Barker was saying that part of the problem might be not enough nutrition when you're growing in the womb. Many in the medical establishment were skeptical.
They attacked David Barker, saying that we know the answer. Control blood pressure, control cholesterol, and heart disease will go away.
So Barker set out to test his malnutrition theory on a larger scale.
India's world's capital of low birth weight babies, far lower than any other population. And I have to say, David Barker was very lucky because he came and met me.
Barker and Yajnik embarked on a decades-long collaboration that would lead to some remarkable findings. In a study published in the International Journal of Obesity in 2003, they compared Indian babies to Caucasian babies in the UK and found that even at birth, Indians had more fat, despite being significantly smaller and often malnourished. And when they followed a cohort of Indian babies over the first 8 years of their lives, they literally added a new dimension to our understanding of diabetes.
Take this graph, for example, showing the correlation between insulin resistance and a given child's weight at 8 years old. Not surprisingly, the heavier children had the worst results. But adding birth weight to the equation suggested that another, previously hidden factor was also at play. It was actually the children who were born the smallest and then gained the most weight as kids who seemed to have the highest risk of diabetes. And in a country undergoing an extremely rapid economic transition, this was an increasingly likely scenario. Your mother might have been undernourished when she was pregnant, but you could grow up eating at McDonald's. And yet, if there's something about malnutrition in the womb that puts you at risk for diabetes, what is it?
To try to answer that question, Yajnik and Barker launched an even more ambitious study. They started by tracking the health and nutrition of a couple thousand rural women. Those who became pregnant were followed up with, and their children became the focus of the Pune Maternal Nutrition Study, which has now been running for 18 years.
Yeah, so see, we have over 800 in our cohort, children, and then twice that number of parents.
So it's 2,400 people total.
That's right.
It's a major undertaking.
Major undertaking. And we follow the children from birth every 6 months for their growth measurement. And then every 6 years we call children and their parents for very detailed studies of growth, body composition, metabolism, hormonal status, neurocognitive findings, and XYZ. We have done it on hundreds of people for last 20 years.
And so how long does it take to go through this whole cohort?
About 1.5 to 2 years.
Just to get all these measurements.
Yes.
It also takes a massive team of social workers, number crunchers and administrators, lab technicians and researchers, and clinicians.
Where are we heading?
Okay, we are heading to the villages near Pune.
Dr. Yajnik took us to meet two of the subjects of his study.
So in this 20 years that you've been coming out here, a lot has changed.
The way things have changed in last 20, 30 years is just mind-boggling. They used to fetch water from the well. They have now piped water supply. Electricity has become more common. About 70% of the houses that time were electrified. Now it's 95%. 0% of our families had a four-wheel vehicle. Now 8% of our families have four wheels.
And of course, these kinds of changes, which are happening all over India right now, can have a big impact on diet, physical activity, and ultimately the health for hundreds of millions of people, like Pooja and her mother Savita.
She is the representative of F0 generation.
And what does F mean?
She is F1. So this is a term in genetics.
Yeah.
The first generation, the index generation, we call F0.
Okay.
F1 is the offspring, and her offspring will be F2. And then there will be F3, 4, which will be beyond our time. Yes.
Maybe we could talk a little bit about Pooja's
Pooja,
story.
yes. So she weighed 2 kilos and 550 grams.
That's still quite small.
Still quite small. Pooja's mother before pregnancy was 40 kg, which compared to an American Institute of Medicine standard, she will be classified as undernourished before pregnancy. And undernourished people are supposed to put on more weight. So she would be expected to put on something like 12 kg or more. She put on only 7 kg. So this is the shift of the spectrum we have of nutrition, body weight, gain of weight in pregnancy, and that is how it reflects in the low birth weight of the children.
During Savita's pregnancy 20 years ago, they monitored her diet, including the level of vital micronutrients in her blood. They also tracked her physical activity.
So they do the whole work of the house, bring water and everything, and then 6 hours they are on the field in this hot sun, and then again would come back in the evening and do cooking, because it's so hot here that the even morning food would go stale in the evening. And this physical activity is there till the 9th month, till she will deliver.
After she was born, Pooja's growth was recorded every 6 months. And every 6 years, she was subjected to a battery of tests.
तुला कधी लक्षात आलं की तू आपल्या पुणे स्टडीमध्ये आहेस?
तरी या 10 वर्षाची.
10 वर्षाची. तिथे तुला हे घालून लावलेलं.
एक जनरल नॉलेजचा पेपर पण घेतला होता मी जेव्हा लहान होतो तेव्हा. काहीतरी लिहायला दिलता मला. एक ठोकळा होता त्याचं काहीतरी बनवायला सांगितलं.
Excellent, very good. So I think she is remembering more than I do. Yeah.
And this was at 6 years.
It's at 6 years, then 12 years, and recently when they were 18 years.
What they were looking for was some kind of correlation between Pooja's health and her mother's diet from years earlier. What they found was a complex web of interactions between lots of variables. But one factor in particular stood out: vitamin B12.
Our most dramatic finding was that mothers who had low B12 concentration in the blood in pregnancy, their children had some difficulty handling glucose, and we call this insulin resistance.
So far, this is just a correlation, but it's another data point in support of what has come to be called the Barker hypothesis, that adult diseases can be traced back to factors early in life.
We say non-communicable diseases as opposed to communicable diseases. And now we are saying they can be communicated from the mother to the children by actually environmental influences.
It's a major new way to think about diseases like diabetes, and it happens to dovetail with recent developments in the burgeoning new field of epigenetics. It's the idea that your environment, including chemicals like vitamin B12, can actually change your DNA.
Above the genetic structure, something happens which changes the transfer of that information, what we call epigenetic changes. Epi means above, and genetic is genetics. So code remains the same, but it changes the way that gene expresses.
This is a big deal, right?
Yes.
I mean, this is like a major sea change
Yes.
in sort of classical genetic thought, right?
Yes. And the classic example where I learned it very, very well was on the agouti mice.
So these are the famous agouti mice?
These are the agouti mice.
The Environmental Epigenetics and Nutrition Lab at the University of Michigan, headed by Dr. Dana Dolinoy, is one of the numerous places where scientists are now studying how DNA is affected by environmental factors.
What you can immediately see is that they range in coat color from brown to a mouse that's purely yellow over here. And what's also really interesting about these mice, they're genetically identical.
They have 100% the same DNA.
Yes, but what's different is their epigenome. It's a series of molecular switches and markers that tells genes when to turn on, where to turn on, and how much to turn on.
And as a result of genes being switched on and off, these mice will have very different futures, even though they have the same genetic code.
At birth, they are all the same size. They all look identical except for the coat color difference. But over time, the mice that have the yellow coat very early in life will grow more. They eat more and they will become obese, whereas the brown and black mice remain lean.
The yellow mice also go on to get diabetes because of the dysregulated expression of this agouti gene, while their genetically identical brown counterparts are protected from these outcomes.
Scientists have identified a number of environmental factors that seem to play a role in determining whether a pregnant mouse's offspring are more likely to be brown and thin or yellow and fat. Dr. Dolinoy's lab has been studying the effects of BPA, which is found in many plastics, and seems to push the mice towards yellow. And an earlier study out of Duke University found that B12 is on the list of compounds that seem to make the mice brown and healthy.
An individual's epigenome is constantly changing across time, but you're most vulnerable in development. If you could intervene early in life and turn a yellow mouse brown, that's a really great starting point to be able to think about translating this to humans.
In medicine or in clinical practice, we have what we call levels of prevention. So we have primary prevention, secondary prevention, tertiary prevention. All doctors are trained for secondary and mostly for tertiary prevention. All you are doing is you lost 3 toes, so I am preventing now the 4th toe from going, and I can't be very sure, and it's very frustrating. You are seeing end stage conditions all the while. The research in the intergenerational and early life has brought in one more type of prevention, which is called primordial prevention. And primordial prevention comes even before primary prevention, where you are reducing the susceptibility so that you are producing a better blueprint on which different factors acting will produce less damage.
Dr. Yajnik is already starting to focus on primordial prevention, as the young women who have been participating in his study their whole lives begin to have babies of their own.
It's quite small, tiny, 2 kg.
Yajnik and his team are running a trial to see if providing better nutrition to these mothers during pregnancy, including supplements of vitamin B12, will reduce diabetes risk for their babies as they grow.
She is the F2 generation in the Pune maternal nutrition study. Her grandmother was our F0 generation. Her mother is the F1.
Is this considered non-controversial that the risk factors for diabetes are being passed from mother to child?
Yeah, to me it's non-controversial. And as a scientist, you have to believe in something. Then you work to disprove yourself.
And have you done that to try to disprove
That's
this?
what we have just now started the trial. It's to be understood that evidence in such matters comes slowly because we are looking at evolution along the life course. So in 5 years' time, when our first round of data collection is over in this, I'll be able to tell you more confidently what we have achieved.